Welcome to question 9 of the 2006 VCAA Mathematical Methods Exam 1. In this video we will be looking at the solutions and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And before we get into the problem, I'm just going to point out that the examiner said that this should have been a straightforward question of a common application of maximum and minimum type problems. However, this was not the case. So for question 9, we have a rectangle x, y, z, w, has two vertices x and w on the x-axis and the other two vertices y and z on the graph of y equals 9 minus 3x squared, as shown in the diagram below. The coordinates of z are a, b, where a and b are positive real numbers. For part A, we're asked to find the area, capital A, of rectangle x, y, z, w in terms of lowercase a. So the first thing we need to do is remember that the area of a rectangle is simply equal to the length multiplied by the width. So for this question, we can see that this would represent the length, and it goes from negative a to positive a, giving it a length of 2a. And the width, or height, is going to be equal to b, and b in terms of a is simply 9 minus 3a squared. So that's the function's value, or function's y value, at a. So what we need to do next is substitute in what we found. So the length was 2a, and then we multiply that by the width, which is 9 minus 3a squared. And when we expand that out, that gives 18a subtract 6a cubed. In the examiner's report, we can see that only 37% of students received the full 1 mark for this problem. And that was because some students often expressed their answer in terms of A and B, not simply A, and quite a few students had the correct response initially, but then proceeded to expand the expression incorrectly, which is a danger that happens in these sorts of questions. For part B, we're asked to find the maximum value of A and the value of A for which this occurs. So up here in blue, I've just rewritten what we found previously, and that is the area in terms of A is equal to 18a minus 6a cubed. And if we want to find a maximum, we know that we can use calculus to help us do that. So we're going to calculate dA, so the derivative, and we're going to set that equal to 0 to find the maximum. Therefore, we have the derivative of a is going to be 18 minus 18a squared, and we set that equal to 0. And then to solve this, we're going to factorize it because it's a quadratic equation. So we take 18 out as the highest common factor, and we're left with 1 minus a squared equals 0. And now, recognizing that the bit remaining inside the brackets is the difference of two squares, we can write this as 18 times 1 minus a times 1 plus a is equal to 0. And then using the null factor law, we find that 1 minus a could equal 0, or we could have 1 plus a is equal to 0. And solving both of those equations, we find that a equals 1 or a equals negative 1. However, from the question we know that a and b are positive real numbers, which means that a equals positive 1 is the answer that we're looking for the value of little a that gives the maximum area. The maximum area, capital A, evaluated at 1, is then going to be 18 times 1 minus 6 times 1 cubed, which gives 18 subtract 6. Therefore, the area of the maximum is 12. And that is the other answer that we were looking for in part B. For question 9b, we can see that 21% of students received full marks, and the comments by the examiner indicate that many students had no idea what was required and attempted to integrate that particular function. Students are reminded that integration would find the area under the curve, not the area of a square inscribed under a curve. Others tried solving 9 minus 3x squared was equal to 0, however that would find the x-intercepts of the curve. Again, that is not the area of the rectangle. And finally, the comment is made that those students who knew to differentiate and then equate to 0 were usually successful in answering this problem. Some students forgot to obtain the area after they correctly found lowercase a.